Okay. So we have this problem. We got a system, two equations. We want a graph that's solved by elimination. Okay, so I'm just going to pick numbers for my A, B, F, and G. Let's say it's 3x plus 2y. Nobody's going to have 2 equals F. Let's say that's 18. And 5x minus 11y equals 24. Okay. If I have this system, then I'm going to graph it. Now, everybody did that right, except, one of course, got a sign wrong. That's no big deal. So everybody's good with graphing. So I'm going to do that kind of quickly. Elimination is, about half and half here. So we want to be sure to get that. Okay, so by graphing, the x-intercept here, well, that occurs when y equals 0. You don't want to shortcut it. You want to do that substitution step that everybody did it. So keep doing it. Okay, well, 3x comes out 18, so x equals 6. The y-intercept. We get y equals 9. Okay, so we want to come out at least to x equals 6 and probably a little beyond. So let's put 6 right here, which means 3 would go here. So we have 1 and 2 and 4 and 5. And 9 would be out about here. We have this point. And then y equals 9. So let's put 9 up here. I'm going to divide that into thirds. I'm going to divide each of these into thirds. And I'll have this, and I'll have then a straight line here that more or less depicts the equation 3x plus 2y equals 18. Now, I'm sure everybody understands that. So, if I see a question, I'll answer it. But since everybody did it right, include it for people who maybe aren't here today. Okay. And again, what we've done here, the x-intercept occurs when y equals 0. So we get 3x plus 0 equals 18, 3x equals 18. The y-intercept occurs when x equals 0. If we let x equal 0, we get 2y equals 18. We solve that easily. We plot 6, 0, and 0, 9 on our graph, draw a straight line. We got our model. And then for 5x minus 11y equals 24. I'm not going to write it out. Just the x-intercept is going to be 24/9, 0. Clearly, if y is 0, it's 24/5. I don't know where I got 9. 9 was still bouncing around in my circuits here. And that's what got written down. Watch today. Okay, so the y-intercept is 0, negative 24/11. Okay. Now, where's 24/5? Well, that's 4 and 4/5, right? Okay, so 24/5 is 4. Here's 4, here's 5. 24 and 4/5 will be like this. Actually, a little bit more to the right. And negative 24/11. Well, 11 goes into 22 twice. with 2 left over. So you would get, dividing 24 by 11, you get 2 and 2 11ths. That's negative 24, so it's negative 2 and 2 11ths. Now 2 11ths is pretty small, it's less than 1/5. So if we come down here to negative 24 11, 0, negative 24 11ths, and it's negative 2 and 2 11ths. It's a little below negative 2, not above. So I don't know why you all did that. Get it straight, okay? Okay, well, let's see. As I say, keep an eye on it. Let's do that up a little bit. Okay, so let's do it right. It's negative 1, negative 2, negative 3, be about here. Negative 2 and 2 11ths would be about here. Negative 2, yeah. And over here, you have all right, it is 24 fifths, 0. We got a picture that looks like this. And the pictures you all got look a whole lot like this one, with just a little bit of variation, of course, in the actual coordinates. So, if you click labeling, there's 6 0, there's 0 9, and this equation is 5x minus 11y equals 24. We estimate our intersection point. Well, here's x equals 5, here's x equals 6. This looks like about, I'm going to say, looks like about 5.6. I'm looking at the graph a little closer than you are, and I don't have any great confidence that's a good estimate. But I'm going to say, okay, this point of intersection appears to be, to me, about 5.6. And over here, it looks like 1.5. Now, if that's really close, I'll be really surprised because my markings weren't all that, my scale on the axis wasn't all that great. And everything's kind of small there. Okay, now let's go ahead, because as I said, everybody seems to have done real well with this. But let's see what happens if we try to eliminate x. Okay, because we're doing elimination. Well, our first equation, I've given myself enough room here. Yeah, just in case I better move. Okay, so we have so I'm going to call this equation 1, this equation 2. To eliminate x, I'm going to say these are relatively prime. Okay. There's no number that divides 3 that also divides 5. In that case, I can multiply first equation by -5 and the second equation by 3. Because if I multiply 3x by -5, I get -5x. And if I multiply 5x by 3, I get, did you hear what I just said? I told you I'm not doing great today. Okay, I don't know what it is, sleep or whatever, but weather, gremlins, I don't know, something. But okay, again, if I multiply first equation by -5, I told you I got -5x, didn't I? You heard me say that. You might not have noticed, or you're just being polite. Okay, Negative 5 times 3x gives me negative 15x, right? It's important that I say this right. And 3 times 5x gives me plus 15x. Well, that's cause for joy because when I add them, my x's are going to go away. Negative 15x plus 15x is 0. Okay? I've got it straight. If you got it straight, I think you already did. Okay, so we get negative 15x times 10y equals negative 90. You can do multiplication. I'm not even sure I'm going to do that right, so watch me. And here we get then plus 15x, multiplying the second equation by 3. 3 times negative 11 is negative 33. And 3 times 72 is 72. 3 times 24 is 72. Okay. If it wasn't pathetic, it would be funny. Okay. Now, if we add these, I'm going to get 0 here, right? I'm going to get negative 43y, because negative 10y and negative 33y is negative 43y. I'm really paying attention. And I think that's right. Okay. Now, I'm not sure I'm still paying attention, but I think that's 162. Okay. Well, that gives me negative 43y. 90 and 72 is 162. And that's what you get if you don't see that little negative sign there, which I should have remembered from having written it only 10 seconds earlier. Okay. I don't know where this ends, but it's kind of, if it wasn't pathetic, it'd be funny. Okay, so it's negative 18. So we get negative 43y equals negative 18. And then solve for y, negative 43y over negative 43 equals negative 18 over negative 43. Okay. Well, that's less than a half, which means that my lines really should have crossed a little bit lower. Okay. So my estimate isn't all that good, but here we have it. We see that y is then 18 over 43. And that's kind of close to 0.4. Now you see on my graph here, 0.4 would be down much closer between 0 and 1. It'd be down much closer to the x-axis. Be a lot lower. I don't have a good explanation for how the line, which looks like it kind of went through the right points, ended up that high. But that's what happens when you draw a freehand line. Okay, I'm a little surprised I didn't do better than that, but the way I'm doing today, I'm not surprised at all. Okay, now what do? We take that y equals 18/43, not our decimal approximation. We stick with the fractions and then we can do decimal approximation because the answer might be pretty, in this case it wouldn't be, but you never know when the answer is really sensitive to little changes in this number. So this number is not going to be exactly equal to this number. It's going to be like negative 0.39 something, probably, or 38 something, if you actually divide it out. It'll be a little less than 0.4. So we're not going to use that. We're not going to use 0.38 or 39. We're not going to use a 4 decimal place approximation because that gets ridiculous. Okay, we're going to use a fraction. So we're going to bring that fraction back up into one of our equations. Now, I really don't want to take the chance of multiplying this by negative 11, although we get negative 198 over 43. Okay, I'm pretty sure that's right. But I'm not going to take that chance. I'm going to come up here and say, okay, I'm going to plug this in for y here. And that brings me back down to this equation, 3x plus 2 times 18/43 equals 24. Yeah, that might work. It don't work all that well. Do something really dumb. No. Yeah. Okay. It's predictable. Okay. Right hand side of this equation is 24, it's 18. Now I'm pretending to make a lot of mistakes here, so you are aware that you need to also be careful to check what you're doing, okay? Now I'm going to stop making mistakes and I'm never going to make another one in my entire life. You believe me, don't you? And be careful after handling that radioactive waste, what you agreed to. Okay, okay, so let's see if we can do this right. Okay, so how do we solve this? We multiply both sides by 43. Because we have a denominator, and one principle of solving equations is if you've got denominators, just multiply them out. The denominators go away and you get something much easier to deal with. You don't have to deal with the fractions. So I actually said that right, I think. Now, 43 times 3x plus 43 times, well, 2 times 18 is 36, right? And I can do that. I can multiply numerators and denominators. So I'm going to kind of do this to avoid a little bit of possible confusion. You get this. 43 times everything. So 43 times 3 is 129. Now, I'm going to write it out over here again. You're going to want to draw lines through this and cancel. Okay? I don't want you to do that, but you're probably going to do it anyway. We can say 43. Keep reviewing this. There's a reason you can cancel those. And unless you really know the rules, you're not going to be safe canceling. Okay? 43 times 36 over 43. Of course, we write that as 43 over 1 times 36 over 43. That's the same as 43 over 43 times 36 over 1. Now, this is not by some rule that you can move this over here and you can move that over there. It's because when you multiply the numerators, you get 43 times 36 up here, right? When you multiply the numerators down here, what do you get? 43 times 36. So you get the same numerator down here as you have up here. What about the denominator? Well, you got 1 times 43. What's that give you? Well, that gives you 43, right? Down here, you got 43 times 1. You get 43. You get the same exact thing from this expression you do from this one. But this divided by this is 1. So that's 1 times 36 over 1. Now I get a little more ridiculous here, but it should be very clear that that's 36. 36 over 1 is 36, and 1 times 36 is 36. Okay, so this is 36. Not because you cross this out and this out, although you can in this case, but because of properties of fractions that you need to understand, okay? And I'm going to leave this as 43 times 18. I don't want to multiply that right now. I think I might come out with something a little simpler. Okay, this is a multiple of 3. This is a multiple of 3, and this is a multiple of 3. So I'm at least going to be able to divide by 3 here in a minute. It's going to make my calculation a little simpler. So we get 129. Now, if you got a calculator, it's fine to use it to multiply that out. What are you going to get? You're going to get 430 minus 36, which is 394, I think. except that 394 is no more than 3, so what's wrong with that? 430, no, I'm sorry, it's not 430. You multiply by 20, it's 860 minus 36, which is 724, which still isn't a mole. I don't know. Something isn't checking out, but notice that I'm checking. Okay, keep checking yourself. Okay. Well, I could get fancy. I can divide this by 3. I can divide this by 3. I can divide this by 3. Wouldn't necessarily be a bad thing to do, but I'm going to just go ahead and do this. Now, let's see. I get 860 minus 2 times 43, and 2 times 43 is 236. 2 times 18 is 36. So I just did another haywire calculation. 2 times 43 is 86, and you divide that from 860, you get 754. That's not a multiple of 3. Boy, something's going on in my brain here. You get 860 minus 84. Now 60 minus 80 is 60. And it's 6. Somebody multiply that up. I keep getting 754. I know that can't be right. 774. Okay, 774 minus 36. I'll bet I can do that. Okay, because 774 minus 30 is 744, and subtract 6, you get 738. And that is a multiple of 3, so I'm a little more confident of that. Okay. And now, again, don't skip steps, but X is 738 over 129. Now 120 goes into 720 6 times. 129 will go into 720 a little less than 6 times, but it'll go into 738 a little more than that. So I'm saying that's going to be a little less than 6. And of course, my estimate was a little less than 6. Okay, should have been a little bigger, probably 5.8 or something like that. Okay. Now you don't have to do the estimates, but I'm kind of talking about the nature of numbers here and trying to get you to think a little bit more about numbers. Anyhow, so you can divide that out in your calculator. You're going to get something like, let me guess, 5 point. You're going to subtract about 4. It might be pretty close to 5.6 actually. What do you get? Okay, can you convert that H5 and 31/43? Okay. Okay. Well, that's about 3/4, which would be 5.75. 43 is a little big, so it's a little, probably close to 5.7, maybe closer to 5.7 than 5.6. Okay. Now, the whole point of that is it's kind of a game. See how close we are. This was pretty close, but that really sucked. Okay. That was not good. And I still don't know what was wrong with my picture. I get a little uptick there, but it doesn't explain it all. Okay, point being that this gives you an accurate result. Okay, if you don't do the arithmetic in your head like I did, because I kept doing things wrong. Okay, and usually do a little better than that. But your calculator is going to carry you through this calculation, but don't round things off until you get to that last fraction. That's my main point. Because any error you make in rounding off here keeps compounding itself all the way down to here. In this case, it wouldn't be that bad a thing, but sometimes it is. Okay. That's the process. Now, let's see, we've got 30 minutes. we really need to move on. And talk about a system of three equations and three unknowns. I'm going to give you one that's fairly easy because we don't want to get hung up in a lot of obnoxious arithmetic. And you can't graph these. I mean, they can be graphed, but you have to go to a three-dimensional graph with planes intersecting and stuff like that. And you're not equipped to do that. Most people aren't equipped to do that. Okay. Most engineers can't do a very good job of that because they rely on software. So I'm not going to ask you to do something I wouldn't ask a fully fledged engineer to do. But unless you want me to. You want me to do that? No, you don't. Okay, so let's say we got 2x plus 5y minus 4z equals. Okay, I'm going to make this really easy so I don't really screw it up. That's going to equal 3. And see what that is. That should be 6. Okay, and x plus y minus z equals 1. Okay, we want to solve this by elimination. Let's call this equation 1, call this equation 2, call this equation 3. Now, the easiest thing to do, it turns out, is just write these equations in a different order. Okay, with the first one first. I'm not going to do that right now. Okay, but I'll explain after we do this why that would have made it a little bit easier, but it's not going to be too hard. Okay. Actually, I'm going to do that. Make it as easy as possible. Okay, so I'm going to rewrite the system of equations with this one first. Okay. The reason is this x has a 1 in front of it. So what do I get if I add okay, I'm going to write it down. I'm going to write x plus y minus z equals 1. I'm going to leave that first equation as it was. The second equation, I'm going to do equation 2 minus 2 times equation 1. So I want to leave myself a little more room here, so I'm just going to rewrite this first equation. What I'd like you to do is take this equation and multiply it by 2, by -2, and then add it to this one. Okay? I'll come around and see if you're doing this. Why not see? Now, when I do this, equation 2 minus 2 times equation 1, I'm not going to do it below here. I'm going to do it off to the side. So I'm going to say equation 2 minus 2 times equation 1 is what? It's here's equation 2. Okay. And here's equation 1. Let me write this. Okay, well, here's equation 2. I want -2 times equation 1. Okay. So go ahead and write this down. Just write down what I did, but then show me what -2 times equation 1 is and write it down here. Okay, now people are having a little trouble with this. Most people, and you know, the main trouble, and just take a lesson on it. I said, write this off to the side, write this, and write this, and write this, and then fill it, okay? Okay, most people went and did what I always say to do. If I tell you something I need you to do, dive into it, right? Most people dove into -2 times equation 1, okay? Now, you want to do that, but remember what I said was first write this, and write this, okay? So make sure you do that, at least until you really understand this process. Okay, so, okay, well, -2 times equation 1 is, well, -2 times x and -2 times y, -2 times -z, and -2 times 1, right? So I'll even write that up here. Off to the side. I don't want to write anything below this, and you'll see why. You know, right now you don't, so a lot of people wrote stuff below here. Okay, you want to avoid doing that so you can see the sequence of how these things develop, okay? So kind of do these side calculations off to the side. So I can do a side calculation. I can do it anywhere except below here. You probably don't want to do anything below this either, so we'll do it. So we do -2 times equation 1 is what? -2 multiplied by x plus y minus z equals -2 times 1. Because you multiply by equation 1, that means multiply by both sides of the equation, right? So multiply -2 times the entire side here and -2 times the entire side here. Well, the entire side here is just 1. But over here, it's the x plus y minus. Then we use the distributor's law. We get -2 x minus 2y plus 2z. Over here, we get -2. That's straightforward, but you want to be careful because people are making some errors on multiplying sign numbers and stuff like that, and trying to shortcut it. You want to shortcut it so you really understand. So we come down here now, and -2 times equation 1 is this, and now we can fill it in here. Okay, we don't want to confuse it by doing all this right here because we want this, and this. Okay. And once we have that, it becomes pretty clear. What's going to happen next? Okay. Now we have this to this, so this would be equation 2 minus 2 times equation 1 is going to be what we get when we add this to this. -2x and -2x gives us 0. 5y and -2y gives us 3y. -4z and 2z gives us -2z. 3 and -2 gives us 1. Okay. Now we don't even really need to 0 there, so I'll kind of halfway erase it, smudge it a little bit, so you can still see it, but it doesn't really have to be there. Okay. And now we can write equation 2 minus 2 times equation 1 up here. That's going to be just 3y minus 2z equals 1. Okay. We've eliminated x by adding -2 times this to this. Okay. Now, we're going to calculate equation 1 minus 4 times equation 3. And I said that exactly wrong, because every chance I get today to state something wrong, I'm going to take advantage of it. Okay, it's equation 3 minus 4 times equation 1. Now think about why we did this. If we multiply this equation 1 by negative 4, we're going to get a negative 4x, right? And if we add it to this, x is going to go away again. Okay? So our x's are going to go away if we do this. So how do we write this out? Write this out, equation 3. And then negative 4 times equation 1. Then equation 3 minus 4 times equation 1. Imitating what you did up here. And if you're going to calculate negative 4 times equation 1, do it someplace else. Don't do it here. Scratch it out somewhere else on your paper. Okay? But not below here. Okay. Now, when I say again, write this out, then write this, and write this, and write this. That's exactly what I mean. Don't write anything else in here. Okay. Now, you do negative 4 times equation 1, you might need to do that someplace, but don't do it here. So you can, okay, negative 4 times equation 1 would be negative 4 times x plus y minus z equals negative 4 times 1. So you get negative 4x minus 4y plus 4z equals negative 4. So there it is. Okay. Now we can take this, which we did someplace else, and put it into the form of what we need to do here. Negative 4 times equation 1 is negative 4x minus 4y plus 4z equals 4. Now we have a space here for equation 3, right? So we write down equation 3, which is 4x minus 3y plus 5z equals 6. And you know, when I copied this down, keeping with my apparent inattention today, I didn't get the negative sign, but there it is. Okay, so I copied down equation 3. I've calculated negative 4 times equation 1 up here. So now I can copy it down here. And then I can add these. Negative 4x and negative 4x is 0. Negative 3y and negative 4y is negative 7y. 5z and 4z is 9z. And that gives us 2. So now up here, that's what I'm going to write out. I'm going to write out equation 3 minus 4 times equation 1 is negative 7y plus 9z equals 2. Now what I have is I have 2 equations in 2 unknowns. And we already know how to do 2 equations in 2 unknowns, assuming we've mastered the assignment for today. And if not, we'll need to go back and do that first, okay? We have to get master the elimination of 2 equations. What we're going to do here, we're going to multiply this by 7 and this by 3, which will give us 7, 21y and negative 21y. Y goes away. We get an equation with just z that we can easily solve. And then we back substitute, okay? If we've got a number for z, we can plug it in here and solve for y. Then we'll have a number for y and a number for z. We can plug it into the first equation, then we get our solution. Now, open math will show you a lot of that. We had a little trouble with arithmetic today. Fortunately, I've left plenty of time at the end of the course to mop things up, because this is your last assignment. And now we can talk about things that we need to talk about, okay? To prepare you maybe for things you're going to see in your course, or things that you didn't understand and things that are coming up and so forth. So we're going to have a couple of weeks to do that, okay? So if it takes us a little more time to get this, we've got a little more time. If we need a little more time on something else, we've got a little more time. And if other different people have different things they need to look at, we can do that. So there aren't that many of you. Okay. Hopefully some more will come back to class, but there we've got it.